Hi there, this is Mr. Schnitzius, and in this video we are going to conclude our review of the North Carolina end of course geometry assessment by going over numbers 46 through 60. Number 46 says the ratio of the height of the pyramid to the edge of the square base is 1.5 to 1. The height of the pyramid is 3 meters. What is the approximate length of the slant height of the pyramid? So for this problem, we need to recognize that there is a right triangle formed here between the height, half the base edge length, and the slant height. So we're going to put a right angle right there. We know that there's a ratio of the height to the edge of the square base. So we're going to write that as a proportion. The ratio of height to edge is 1.5 to 1. So the height here is 3 meters. How long is the base edge? Well, this is pretty easy to see that we're doubling this 1.5 to get 3 meters. So doubling 1 would give us a base edge of 2 meters. But if the whole base edge is 2 meters, then the leg of the right triangle is going to be 1 meter. And now we can use the Pythagorean theorem to help us get the slant height. So that is going to be 1 squared plus 3 squared equals, we usually use L for the slant height, equals L squared. So that's 1 plus 9 equals L squared. 10 equals L squared. And if we do the square root of both sides of this equation, then we get the value of L is about 3.2 meters. Number 47 gives us a triangle and asks us how long is the length of segment EF. Well, segment EF is this length right here, and that segment is a midsegment. How do we know it's a midsegment? Well, a midsegment of a triangle connects two midpoints of a triangle, and we know that points E and F are midpoints because they split the sides that they belong to into half. So if we know that segment EF is a midsegment, we know that it is parallel to the side of the triangle across from it, the 70-foot side. And also the length of segment EF is half the length of the side that's across from it, so half of 70 feet gives us 35 feet, which is why the answer is D. Number 48 says, according to the map, the road connecting the cities of Oakton and Ridgeton intersects the road connecting Mapleview and Pineville. If the roads intersect in the town of Forest Grove in the diagram, which statement is always true? Well, something that we know is always true is that vertical angles are always congruent. So if we can find two vertical angles, such as angle OFP and angles RFM, those have to be congruent. Angles RFP and MFR would only be congruent if these roads are perpendicular, which it does not tell us, so we can get rid of B and C. It did not tell us that F is the midpoint. Segment MP is the same as segment RO. Well, it did not tell us anything to make us believe that, so we have to stick with, I'm sorry, I crossed out C when I meant to circle C. Yes, these are the vertical angles, which is why C is the answer. 49, in circle O shown below, segment RS is congruent to segment ST. What kind of triangle is triangle RFT? Well, this is an inscribed angle, angle RST. How do we know that? Because the vertex of that angle lies on the circle. We know that the measure of an inscribed angle is equal to half the measure of the arc it intercepts. Well, since Point O is the center of the circle, and we know that because they called this circle O. Segment RT is a diameter. So what's the measure of an arc intercepted by a diameter? The diameter splits a circle in half, so that measures 180 degrees. So the measure of angle RST is going to be half of that arc, or half of 180 degrees, which is 90 degrees. So if that's a 90-degree angle, then this is going to be a right triangle. 50 says figure JKLM is a parallelogram. What is the value of x? Well, we know that opposite angles in a parallelogram are congruent. So which angle is opposite angle K? That's angle JML. So we know that the measure of angle JML is 125 degrees. We also know that we've got a triangle right here where the complementary angles have to be, the acute angles in that right triangle have to be complementary. Why is that? Well, because we've already used 90 degrees right here. 90 plus 20 is 110. Take that away from 180 degrees, you get 70 degrees left over. So if angle K measures 125 degrees, that tells us that that's equal to the measure of angle JML. But now we can use the segment addition postulate because we know that the measure of angle JML is equal to 70 degrees plus x. So if we substitute 125 degrees for that measure of angle JML and subtract 70 degrees on both sides, that's going to give us that the value of x is 55 degrees, which is B. Number 51 says, given line segment LP, the length of segment LM is 3x plus 1. The length of segment MN equals 4x minus 3. The length of segment NP equals 6x minus 5. And the length of segment LM equals the length of segment NP. They want to know, what is the length of segment MP? Well, if we know that the length of segment LM is the same as the length of segment NP, then we can substitute 3x plus 1 is equal to 6x minus 5. This is a pretty easy equation to solve. We're going to move our variables to the right side and our constants to the left side. So that's going to give us 6 equals 3x, and when we divide both sides by 3, we get x equals 2. So we need the length of segment MP. Well, the length of segment MP is made up of the length of segment MN plus the length of segment NP. So we just need to find out what those are. If x is 2, then the length of segment MN is going to be 4 times 2 minus 3. 4 times 2 is 8, minus 3 is 5. We also need to know the length of segment NP, which is 6 times 2 minus 5. 6 times 2 is 12, minus 5 is 7. So 5 plus 7 gives us a total length of 12, which is answer C. Number 52 says, what is the measure of an interior angle of a regular hexagon? Well, a hexagon is a polygon with 6 sides. That value 6 is going to be in when we use this formula for the sum of the interior angle measures for a convex polygon with n sides. So let's use that formula. That's going to be 6 minus 2 times 180 degrees. That's 4 non-overlapping triangles inside the hexagon times 180 degrees is 720 degrees. But if it's a regular hexagon, it's an equilateral and equiangular hexagon, which means that if we want the measure of one interior angle, since all 6 angles are going to be congruent, we can divide that by 6, and that is going to give us 120 degrees for C. Number 53 says, what is the best description of the solid figure shown below? Well, this is a three-dimensional shape, so it's not a polygon. It does not have all the same lengths for all the sides, so it is not regular, so that's why it is answer D, a non-regular polyhedron. Number 54 says, what is the converse of the statement in the box? If today is Saturday, then there is no school today. Well, if a conditional statement is in the form if P then Q, where P is the hypothesis and Q is the conclusion, then the converse is written in the form if Q then P. We basically switch the order of the hypothesis and the conclusion. So if it starts out saying if today is Saturday, we want that to go at the end. And if it ends by saying there is no school today, then we want that at the beginning. So when we look at the answer choices, we need to look for one where it says if there is no school today. That happens in A. It does not happen in B. They left out the no. It does not happen in C, and it does not happen in D. So the answer should be A. If it says then today is Saturday at the end, it does. So that's why the answer is A. Number 55 is not going to be covered on the final exam. You do not need to know anything about three-dimensional coordinates. So we're going to skip to number 56. Okay, it says segment MN is perpendicular to segment JL. So we have 4 right angles right there. All of these statements have to do with the measure of angle PKN. And the best way for me to think about this question is to say, well, angle PKN right here is very clearly bigger than 90 degrees. How do we know that? Because angle NKL is 90 degrees, and angle PKN is made up of angle NKL plus angle LKP. So the measure of angle PKN has to be more than 90 degrees. But it has to be less than 180 degrees because it's less than the sum of these 2 right angles right here. So which statement must be true? Does the measure of angle PKN have to be the same as the measure of angle JKP? Well, it could be if angle PKL measures 45 degrees, but they did not tell us that that is the case, so A is false. B is the measure of angle PKN equals, these are all in degrees, equal to 90 degrees plus the measure of angle JKP. Well, angle JKP is also at least 90 degrees. So 90 degrees plus more than 90 degrees would be more than 180 degrees. So B is false. C, the measure of angle PKN equals 180 degrees minus the measure of angle JKP. Well, again, angle JKP is more than 90 degrees. If you start with 180 degrees and you take away more than 90 degrees, you get something less than 90 degrees, which is impossible for the measure of angle PKN. So the only answer that is left is D. Number 57. We're not going to dive into the answer choices on number 57 because vertex matrices are not covered on the final exam. What I did want to show you is that this appears to be an enlargement. What kind of enlargement we can see when we get the coordinates for points T, S, and R. So T starts at 3,1 and ends at 6,2. Hey, it looks like those are being doubled. S starts at 4,4 and ends at 8,8. Hey, those are doubled as well, both X and Y. R starts at 2,5 and ends at 4,10. So since this is an enlargement, it's a dilation. Since each coordinate is multiplied by the same value, it's centered at the origin. And since that value that it's multiplied by is 2, it's a dilation centered at the origin with a scale factor of 2. Number 58 says triangle NOP has vertices N at 2, 3, O at -1, 4, and P at 3, -5. So again, vertex matrices are in no way going to be on your final exam, but what you might want to know about on the final exam are how to perform transformations. So it says which matrix calculation is used to determine the vertex matrix. We're not going to worry about that. Instead, we're going to show how to do this as a reflection across the y-axis. That means take this point O and reflect it over here. There's O prime. Take this point N and reflect it over here. There's N prime. Take this point P and reflect it over here. There's P prime. You end up with two really wonderfully congruent triangles. And as a reminder, the notation for a reflection is lowercase r with the line of reflection as a subscript underneath. Number 59 says, in the graph below, triangle P prime Q prime R prime is the image produced by applying a transformation to triangle PQR. Which rule describes the transformation? Well, let's write down some coordinates. So the pre-image coordinates are P is at 3, 2, R is at 5, 2, and Q is at 2, 5, whereas the image coordinates are P prime 3, -2, R prime 5, -2, and Q prime 2, -5. Well, if we compare these, it looks like the x values are staying exactly the same. Which answer choices show that happening? B, we're changing the sign, we don't want that. And C, we're changing the sign, we don't want that. But in A, we're not changing anything, whereas in this actual transformation, we're switching the sign of the y value. So that's what's happening in D. So that's why D is the answer to number 59. All right, last problem. Point P prime is the image of point P after a counterclockwise rotation of 90 degrees about the origin. If the coordinates of point P are at -7, 3, if the coordinates of P prime are at -7, 3, what are the coordinates of P? Well, we got here after a counterclockwise rotation of 90 degrees about the origin. So if we end here after a 90-degree counterclockwise rotation, that means that we must have started here in quadrant 1. If you start in quadrant 1 and you rotate 90 degrees clockwise, you end in quadrant 2. So what's the only answer choice in quadrant 1? That's D. And then to see why this is where point P is, if you connect point P and point P prime with two segments that meet at the origin, you get an angle of 90 degrees. All right, that's it for this assessment. Thank you for your hard work. Keep practicing hard. Good luck studying and preparing for your final exam.